And now I'm excited to welcome Alexandros Kouretsis, whose extensive expertise in applied statistics and machine learning originates from his background in astrophysics and cosmology. And as an open source developer and our Shiny expert, Alexandros will be sharing his insights on optimizing efficiency and reliability in Shiny projects using httr2. So let's get ready for some valuable tips. Alexandros, the stage is yours.
So hello everyone, and thank you for attending my presentation. I'm Alexandros Kouretsis. I live in the beautiful city of Athens in Greece. My background is from astrophysics and research software engineering, and I have joined Epsilon where my job is to build advanced data science applications using R. In this presentation, we're going to speak about how to unlock Shiny's potential using httr2, or in other words, how to build Shiny applications on top of functionalities exposed by web APIs. And this is quite an important topic. Today's internet and is built upon web APIs, and we have billions of requests every minute done, and all things in the web are run in the backend by some server that we can access via web API, and also the recent AI explosion, and all these services are exposed through web APIs. So the definition is quite broad. A web API allows different software applications to communicate over the internet. And we have, of course, data that have been exchanged, and the most common data structures that you will see are XML and JSON. And we are following, when we build web APIs, usually what we say the RESTful architecture. And this means that we have stateless communication. I think it is the most important point. And this means that whenever you do an API call or a request, the API has no memory of any previous actions that you have did. And this has been proven quite efficient when you want to scale, and it is very easy to maintain. And of course, we have CRUD operations. Usually in web APIs, these are this means that you can usually just create something, read something, update something, and delete something. And one other important aspect is that when you expose a web API to the internet, you can have a developer ecosystem. And this means that you can have different groups, different people that build on top of the functionality of the web API with different languages. And this is where Shiny with HTTR comes into play. It is an excellent combination that you can use and tap any functionality exposed in the internet. So when I first started in IT, I had to connect to an API. It was in the beginning quite scary. It's something like a black box or an oracle somewhere in the internet. You don't have access to the source code. It has documentation that it might use a lot of jargon. And moving forward a few years now, today, it is still challenging, because whenever I see a new API, I know that I have to go and read the documentation, understand the details and the implementation details of each API. But in general, there are some bottlenecks that usually we have. And this, of course, is to understand the functionality of the API and how we can structure requests, how to handle the responses of APIs, also how to authenticate to an API, how to get access tokens. And there are also countless other topics like optimization, how to test your system that integrates now with an external system, what are the rate limits, etc. So let's see a simple GET request. First of all, in a GET request, I have to declare where is my resource, where is my API endpoint. And here, for example, I'm accessing an endpoint at /API/data. and we are using simple HTTP protocol. In the red letters below, it is a header. Usually there we attach metadata, and this is used to make the API understand what we are asking for and provide further context, like, for example, authorization tokens. And hopefully you will get back a response. And the response, first of all, has some metadata returned to you. For example, here we have a 200 code that it is a success. And of course, the content type, but what kind of data has been returned, which here is a JSON. So httr2 is out now as a stable release, a few months. It is a successor of httr. And it is a package from the tidyverse that promises that it will lower the cognitive bottleneck for you to understand and speak more fluent HTTP and connect to APIs, of course. It provides a plethora of user-friendly functions. You can easily configure headers, and of course it has many functions that can help you for authentication and covers different types of authentications that we have. It provides for you great facilities for response handling and, of course, errors and defining rate limits and other nice things that you can find in the documentation. It is also tidyverse compatible. This is great for code maintenance and making your code more readable. You can chain together httr2 functions. And of course, it is also composable, that it is a great feature, for example, if you have a sign up, because you can create a request object, add some context to it, and then reuse it across your modules. So here, for example, we do a specific request for a key equals value. So how now HTTR comes into play together with Shiny? Shiny, we all know that it is a web framework. From R, we create the UI part and the server-side part of our app. And these two together communicate via WebSockets. And we have this abstraction of a reactive graph. And in general, we say that we have a stateful architecture. It's different from HTTP. And when we are using httr2, what we do is that we connect from the server side of Shiny to external APIs. And that way we can build interactive user interfaces on top of functionalities exposed by, I don't know, APIs that serve some AI agent or any kind of data, etc. So a few code structure tips. First of all, try to use a centralized approach per session. This means that you should have a single responsibility somewhere, like an R6 object or a Shiny module that you put most of the logic about how to connect to the API and most of the context, like, for example, rate limits and progress bars and all that stuff that you can define with httr2. And it will be much easier to have error handling now. And of course, maintenance, updates, identify possible breaking changes to the future, in the future, etc. Here is an example of this. We can consider an R6 class, and you can initialize this R6 class. Now this object encapsulates most of the logic, and you can move this R6 class, for example, to a context so that you can access it from different sessions, from different modules within your Shiny app without having to do this drill down of all your modules. And you can call, for example, the session user data and attach your API agent or your manager or your object there and reuse it across your app. Some also tips for managing API calls. In general, we can get advantage of the stateful architecture. And if you build in a smart way your reactive graph, then you can minimize the number of API calls you do because you don't invalidate parts of the reactive graph if you invalidate them strategically. And Of course, another important thing is you can cache your API calls again and do less API calls from your system. Also share, discuss across sessions. This is another great feature of Shiny, but here I just put a warning. If you are in a pharma context, for example, where you have a JXP data, you have very strict regulations, then you have to let a trace always to the API about accessing the data and who accessed there. So yeah, there might be some more discussion, but generally use it, it's great. Also, as a suggestion, move your CRUD operation. This is create, read, update, and delete actions that you do to an API, to an observe. This is, I think, more natural to move it there because it is an external action. You don't calculate something in Shiny and then get the data and you can do your calculations in a reactive. This is general guidance. It's not like a strict rule, but for error handling now, when you are connecting from Shiny to an external system with an API call to an external API, a lot of things can go wrong, right? You can have like a downtime of a server, a database might be down, you might have connection issues, or you might have built the wrong request, you are missing some key, authorization key, etc. So in HTTP communication, we have all these different codes that signaling particular errors. And we can, in general, put them into classes, into categories. The first one are request errors, where usually they terminate the call stack. And for example, you have provided a wrong parameter, or you are missing an authorization token. And then you have the other class of errors that it is the transient errors, which are, for example, try again later errors. Service is unavailable for the next, 3 seconds. So you don't stop the call stack, you don't interrupt it, you retry in a few seconds. And exactly because we have all these, let's say, things that can go wrong, when you do an API call from Shiny, I really suggest to do it within a try catch. And in that way, you have control over any possible errors and you can inform your users what went wrong. And of course, don't let your app go down and everything goes blank. Also, I highly suggest to use glassed errors so that you have better control on the errors and the signals that you send to the user. This is better to protect your backend and your server-side logic. And you can easily create glassed errors using abort function from Erlang. And on the other hand, for transient errors, again, Google, for example, classifies this as transient errors, try again later errors, and you have functions that you can directly use from httr2. And now for these classes of errors, usually the functions that does not resolve, it will return some message or warning to the terminal, but we can still catch this with calling handlers. It is another great function from base R. And still we can continuously provide feedback to the user. This is great pattern also if you have streaming data or if you are connecting to some AI agent that, for example, provides text back to you in batches. So moving to authentication now. Authentication is another big topic. We have many different patterns of authentication. And the most advanced authentication is OAuth authentication. We have 3-4 different types of OAuth authentication. You can find excellent functions in httr2 and use them. But in general, keep in mind that OAuth authentication will make your life much more difficult. And consider if you really need it always. And if you need it, httr2 is there to help you. Moving on with security, I just want to stress out that Shiny has improved security when we are connecting to external APIs. And this is because you have reduced client-side exposure. And this is because we are connecting and we are doing server-side API calls. And this means that all the headers, all the access tokens, all the information, and the request and response objects are in the server. And we have control of what the client will see, what we will expose and send to the laptop of the user, for example, where they have access only to some kind of a session ID, which pinpoints down the stateful session. And also we have much better control at inputs, right? Because we have all these bindings like select as input. We can control on the input parameters as well very well. So by reducing exposure tokens, we can protect ourselves by easily protect ourselves by many kind of attacks like token theft, replay attacks. Vulnerabilities to our APIs are not exposed, like excessive data exposure and mass assignment. So Sign is great for security in terms of this. Now, for going to optimization, I wanted to stress out about it is great to do async calls, and I wanted to speak about promises and how to hack this to unblock the session, but we actually have now extended tasks out. They will be announced by Joe Cheng later today, and we can really do this as we do in Vue, React, and other frameworks now. Very easy to do an API call, but still keep unblocked the session. I will not spoil the party, just give a fast glimpse. Just put your API calls in extended tasks. Yeah, this is great addition to Shiny, the latest release. And yeah, go to Cheng's presentation to learn more. So putting this together, Shiny and httr2 are great option to create web applications and interactive web apps on top of APIs. And you will have great security, great stability, and improved performance with all these good things that we have there. So thank you for updating my presentation. This is QR code of my LinkedIn profile. Let's stay connected and reach out to me for any further questions.
Thank you, Alexandros. Right on time, like a chef's kiss. Exactly. You're leaving no time left for questions, but luckily our audience is good enough and kind enough to address the questions that already happened in the chat. So I'm happy to see that we cooperate there. Kudos to you, Alexandros, for a great presentation. And let me quote Benjamin Gowen from the chat, who said that Alexandros doing a great job progressing from basics to some deep, good tips. Thanks a lot, Alexandros.
Thank you.
Thank you so much.